paper 14. So let's take a look at the first question. A. Use the list of the formulae MF19 to find the series over here in terms of n. Simplify your answer. So what we need to do, just need to directly use the formula booklet MF19 to look for the sum of the R. So this one we can actually direct apply it. You will get this as the n plus 1 over 2 plus n. Then simplify it. You will get n squared plus the 2n. Done. This will be the answer for question number 1A. Move on. We have a B. Show that this relationship is true. So either we go from left to right or we go from right to left. Okay. So what we can do, it's not only one mark. So we can just go from the right to left. So I will just write down the fractions. Then I combine them together as one. Then the denominator I multiply together. Expand, simplify, then you will get this one as the 2r plus 1. Shown. Equal to the left-hand side. Done. That is the number 1B. Move on, we have question number 1C. Okay, continue from the part B just now. So we use the result in part B and use the method of differences to solve this series. So we just apply the result that we have found in the part B. We write down these expressions. Then use the result in the part B. Split them, become 1 over r squared plus 1 minus the 1 over the r squared plus 2r plus 2. Then we just need to replace the series. R equal to 1 inside. R equal to 1 inside. After that, R equal to 2. R equal to 3. So you can see that the pattern of the cancellations, that we can cancel them in such a way. So we will continue with this pattern. And I will show the last two terms. The last terms over here is n. The last term is n. So it's a 1 over the n squared plus 1 minus the 1 over the n squared plus 2n plus 2. And this is the n squared minus, is actually a n minus 1. It's actually a n minus 1 square plus 1. Okay, but if you expand them, you will get is equals to the n squared minus a 2n plus 2. Then this one, it will be the n squared plus 1. N minus 1 squared plus a 2 of n minus 1 plus 2. So if you go and expand them carefully, you're supposed to get n squared plus 1. Okay, so you cancel them in such a way. So you only remain this as the half minus the 1 over n squared plus 2n plus 2. Okay, so this will be the answer for the part C. Okay. So by the way, just in case you're not so sure, so we can do the expansions over here is a n minus 1 square plus the 2 of n minus 1 plus 2. So you will get n squared minus a 2n plus 1 plus 2n minus 2 plus 2. So you will get this one as the n squared, some cancel, plus 1. Okay, just in case you're wondering. Okay, so now we move on to the part D. D, we want to find the sum to the infinity for the series that we have found in the part C. So this, we just need to use the symbol of limit that approach to infinity. It will be the same as the limit of n approach to infinity for the half minus the 1 over n squared plus 2n plus 2. So at the end, you'll get half. Just like that, done. So this will be the answer for number 1D. Moving on, we have question number 2. A mathematical induction that for every integer that the n greater or equal to 2, and this derivative relationship is true. So what we need to do, we will start from the n equal to 2 because the minimum value of n is 2. So we just say that when the n is equal to 2, your d square dx square of x ln x is actually differentiate the d dx of x ln x. So if you differentiate this, you will get keep the left, differentiate the right, plus keep the right, differentiate the left. So means it's the same as you differentiate the 1 plus ln x. So differentiate 1 plus ln x, you get 1 over x. It's actually same as the x power negative 1. It's actually same as the negative 1 power 2 of 2 minus 2 factorial. X power 1 minus a 2 is the same. Okay. So it's true for n equals to 2. Then I assume true for n equal to k, which means that the xk of x ln x will be giving you negative 1 power k minus 2 factorial, x power 1 minus k. So we assume it's true. Then when the n equal to k plus 1, your dk plus 1 of the dx k plus 1 of x ln x is actually d dx of this. And we just use the result here. That means I just need to differentiate negative 1 power k minus 2 factorial, and x power 1 minus k. So these are constant. When you differentiate, the constant actually can bring out. It's not affected by the differentiations. I just bring the constant out. Then inside here, I differentiate. I get 1 minus k. Then x power 1 minus k minus 1. Okay, so you just need to arrange them in a way that negative 1, k minus 1, k minus 2 factorial, x power 1 minus a k plus 1. Rearrange them everything. So especially this part, I make it become this. Then the negative 1 the power joined together, -1 power k plus 1. And these two combined together is actually a k minus 1 factorial. 1 minus the bracket of k plus 1. True for n equal to k plus 1. Then conclusion I write over here. By the BMI, the dn, dxn of x ln x, it will be equals to the -1 power n minus 2 factorial x power 1 minus n. Okay? For every integer n greater or equal to 2. Okay, done. This will be the answer for the question number 2. Move on, we have question number 3. Have 3 points over here, A, B, C, have a position vector given as the following here. And relative to the origin. Find the equations of the plane ABC, giving the answer in the Cartesian form. So what we need to do at first is I write this OA in a matrix form. So it will be 0, 2, 3. And the OB is a -5, 3, 1. And then OC is a 1, 2, and then 5. So I need to find the AB and the AC. AB will be a -5, 1, -2. AC will be a 1, 0, 2. Take the AB, cross the AC in order to get the normal vector. -5, 1, -2, 1, 0, 2. So do the cross product, you will get this one as a 2i plus 8j minus a k. Okay. So over here, this is my normal vector. My normal vector. Okay. Then equations of plane. We have 4 brackets over here, and there's a dot in between. So this is the normal vector. Normal vector. Your value here is x, y, z, any random point. And this one is a position point. You can put OA, you can put OV, or you can put OC. It doesn't matter because ABC is on the plane. So over here, I put 0, 2, 3. So I have 2x plus the 8y minus the z is equal to the 0 plus 16 minus 3. So it's actually a 13. We can actually write 13. Done. This is the answer for the number 3A. Move on. We have a 3B. Find the perpendicular distance from O to the AB. So we have a AB here, ABC over here. So we have found the normal vector n. And actually there's an O here. We want to find the perpendicular distance. So the n, the distance. Okay. So this one, we have formula. D between the plane. So we just use the formula D is equal to the, let me write down the equation of plane first. The equation of plane is 2x plus 8y minus a z is equal to 13. So this modulus, the formula will be the modulus of 2x plus the 8y minus a z minus a 13 divided by the square root of the 2 square plus x square plus a negative 1 square. So this is the point origin, 0.000. And if we use the calculator, you can get this one as 13 over square root of 69. This is the exact value form. You can leave it like this. If you don't want, you can give me in decimal, 3 significant figure. Done for the number 3B. Move on. We have a question number 3C. Find the acute angle between the line OA and the plane ABC. Okay. So the plane ABC, we already have the normal. Just now this is the plane ABC. And let's say we have a line called the OA. Okay, let's say this is the A. We are looking for this angle. But this angle will be a 90 degree minus theta. Okay, so I will be focusing on the angle between these two lines. Okay, so the acute angle between the OA, just take the OA dot with the N is equal to the magnitude of OA, magnitude N, cos 90 degree minus the theta. So actually will be like this. Since they mentioned acute angle, to make sure it's acute, we put modulus. Cos 90 degree minus theta is actually sine theta. So the OA just now is a 023. So I have a 0 plus 4 plus 9 over here. The normal vector, just now the normal vector is a 2x negative 1. So it will be a 4 plus 64 plus 1. Then you will get sine theta is equal to the modulus of a 0 plus 16 minus 3 divided by the square root of 13 and square root of 69. Yeah, correct. Okay. So over here, you just press the calculator. You can get the answer. The theta is equals to the 25.7 degree. That means we have found that the theta over here is 25.7 degree. That is the angle between the line OA and the plane ABC. Done. Okay. So we are moving on. We have a question number 4. Number 4, let's take a look at the questions, the cubic equations. Look like this, where the B and C are constant and has a root of alpha, beta, gamma. Given that this matrix is singular, then show that the alpha square plus beta square plus gamma square is equal to 3. Okay. So over here, we know that the alpha plus beta plus gamma is actually equals to a negative B. We also know that alpha beta plus alpha gamma plus the beta gamma is equal to C. And alpha beta gamma is equal to 1. Okay. Now, we do not need to use it at the moment, but this is just to highlight over here when we want to solve the problem. So given that this matrix is singular, so singular means what? Singular means that it has no inverse. If it doesn't have inverse, that means the determinant is equal to 0. So we need to find the determinant of this matrix. Okay, because of singular. So just expand them carefully. You have a 1 minus gamma square. Then you have a alpha minus a beta gamma. Then you have a alpha gamma minus a beta. Expand them, you get this. So you rearrange them, 1 minus the alpha square plus beta square plus gamma square plus the 2 of the alpha beta gamma equal to 0. So your alpha square plus beta square plus gamma square is equal to the 1 plus the 2. This one is 1. So that is equal to 3. Shown. Done for the part A. Now move on with the part B. Part B, they give you that the alpha cube plus beta cube is equal to 3. And the constant ABC are positive. Okay. So over here, we will need to let the Sn equal to the alpha power n plus the beta power n plus the gamma power n. Okay, but before we do this, we actually need to find alpha square plus beta square plus gamma square. First, just now we showed that is equal to 3. This is also equal to 3. So this one, when the sum of the square is a 3, sum of the cube is also 3. So that means this one we can use this formula, alpha plus beta plus gamma square minus the 2 of the alpha beta plus the alpha gamma plus the beta gamma is equal to 3, which is a negative b square minus a 2c is equal to 3. So you have a b square minus a 2c is equal to 3. And I call this one equation 1. Okay. Now we let the Sn is equal to alpha power n plus beta power n plus gamma power n. So your cubic equation is x cubed equal to the negative bx square minus cx minus 1 plus 1. Change it to become Sn negative b s2 minus the c s1 plus the s0. So this is S2. So S2 just now is 3. Then the S1. This is S1. S1 is a negative B. This one is a 3. Okay. Then just simplify it. The 3 and 3 cancel. So you will get 3b minus the bc is equal to 0. Factorize the b out. B equal to 0 or C is equal to 3. This one is rejected because of the B is positive. The question mentioned that the B is positive. Okay, yeah. So we have found the C. Then from the equation 1, B square minus a 2C is equal to 3. So the B square is equal to 9. The B is equal to 3 because of the B is positive. Done. This will be the answer for the question number 4B. Moving on, we have question number 5. M represents the sequence of two transformations in the xy plane given by one-way stretch in the directions of in the x direction scale factor 3, followed by a reflections in the line of y equal to x. So we let this call the matrix A, and I let this one call the matrix A B. So over here, I will just let my A is equal to the one-way stretch in the x directions with a scale factor 3. You can direct write like this, and the B is the reflections in the line y equal to x. So usually we just memorize the result. So this one, it will be 0, 1, 1, 0. Okay, we can straight away start from here. Then they say that this is the first followed by the second. Okay, so we know that when you having a composite transformations, so your matrix M will be the BA, because the most right hand side will be the first one followed by the second one. Okay, so it's BA. So that means it's actually the B multiplied by the A. Okay, so we have a B multiplied A. So you have a 0, 3, and 1, 0. That is a matrix M. Done. B, give a full details of geometrical transformations in represented by the M inverse. Okay, so the question is not looking for M inverse because actually for part C, we need to find the M inverse. So over here, they only ask us to give the descriptions, the details of the transformations. So we try to describe them using words to describe them. So your M is equals to the BA. For the M inverse is actually the BA inverse is the A inverse multiplied by B inverse. All of you should know this result. Okay. So now this time, this M inverse, this will be the first transformation followed by the A inverse. So we need to know what is the A inverse. A inverse, if you refer back to the A, this is the A. A inverse will be 1 over 3. And then 1 over 3. Then 1, 0, 0, 3. You can multiply them inside so that you can get 1 over 3, 0, 0, 1. Okay. So then the B inverse will be the B is 0, 1, 1, 0. So it's actually 1 over negative 1. Then these two swap. This one just put negative. And you get back the same transformation as the reflections of y equal to x. So since the order, follow the order, this one first, followed by this one. So therefore, M inverse represent a sequence of just copy down represent. Actually, just copy down this statement. Just copy down this statement. Just copy down represent. But you will need to modify the transformations in between. Okay. So M represent this a sequence of two transformations in the XY plane. Given by a stretch of reflection first, then we only stretch. Given by reflections in the x in the line x y equal to x, followed by A inverse. A inverse is actually a stretch, a one-way stretch parallel to the axis in x directions. With the scale factor 1 over 3. Done. Okay. So these are the two transformation that is important for us. So need to make sure that you describe the transformation carefully. So this is the answer for number 5B. Move on, we have a 5C. We need to find the N. So first of all, we need to find the M inverse. M inverse, just now we know that is the A inverse multiplied by B inverse. So from A, just now is 1 over 3, 0, 0, 1. Then the B inverse is a 0, 1, 1, 0. So if you multiply them, you will get this one as a 0, 1 over 3, and 1, and then this one is a 0. Okay, so this is the M inverse. Then the Mn is equal to the 1, 3, 2, 2. M inverse multiplied by Mn will be equals to the inverse of M multiplied by 1, 3, 2, 2. Okay, just like that. Then this will become N. When you expand them, you get this one as a 1, you get this one as a 2 over 3, you get this one as a 0, and you get this one as the 1. Okay. Okay, so this will be the answer for the question number 5C. Oh, I make a mistake, sorry. This one and this one will not giving you 0. This is it. Okay, my apologies on that. So now we move on to the question D, 5D. Find the equations of the invariant lines through the origin of the transformations in the xy plane represented by Mn. So we let our invariant line is y equal to mx. After you transform, it will become y equal to mx with the uppercase x and uppercase y. So your Mn, following the question in the part C, your Mn is a 1, 3, 2, 2. Multiply the xy is equals to the x and y. But we actually no need to waste our time writing this. We straight away start from x mx equal to the x mx. Okay, so just need to expand the multiply the two matrices over here, product of them. So you will get 1 plus 2m x and the 3 plus 2m x. This one is equal to x. This one is equal to the mx. That is your equation 1. That is your equation 2. Take the equation 1, divide by 2, or 2 divide 1. That is up to you. So I'll just take the first equation number 1 divided by equation number 2. Cancel the x. Then you get m plus 2m squared plus equal to the 3 plus 2m. So you have a 2m squared minus the m minus the 3 equal to 0. Factorize it. It will be a negative and a positive. So your m is a 3 over 2. Another value of m is a negative 1. Okay, so with this, we have found the invariant line. Therefore, invariant line is invariant lines. They are y equal to the 3 over 2x and y equal to the negative x. Done. This will be the answer for the question number 5 and D. Okay, move on. We have question number 6. Where the a is a positive constant and the data is between 0 to 2 pi inclusive. Sketch the curve C and state in terms of A the greatest distance of a point from the pole. Okay, so for the questions over here, we just need to draw the table to plot the point. So we just plot a few points. This is the data, this is the R, 0 to 2 pi. So maybe we can try to calculate the value at 0, pi over 2, pi, 3 pi over 2, and then 2 pi. Okay, so if you just calculate with your calculator, then you will get this point. I just give the answer in the value over here in 1 decimal place. Okay, so this is the table that I have. Then I just need to sketch it properly with the proper scale. This is the data equal to the 0. This is the data equal to the pi over 2. So with the proper scale, so we have a 0.2a, 0.4a, 0.62468, 10. Okay, so this is the 0.2a, this is 0.4a, 0.7a is here. So at the end, your graph will pass through these few points. Okay, so then of course at the beginning data equal to 0. So if you plot all the point in this way, so you can see that it is a spiral. Okay, this is a spiral. And your maximum distance from the pole is A. Okay, that's all. So this is the answer for the number 6A. Move on. We have a 6B. We want to find the area bounded by the region by C and the initial line. Okay, so that means the areas over here just need to integrate half R square d theta from 0 to 2 pi. And the R is tangent, A tangent theta, 1 over x theta. So it will be A tangent 1 over x theta square. So it will be the 1 over 2 half A square 0 to 2 pi tangent square 1 over x theta d theta. So to integrate tangent square, we need to convert them into using the trigonometric identity, using the secant square. So you will get these relations is tangent square is a secant square minus 1. Then just integrate. Integrate secant square, you get tangent. This will be 8. This is a theta 0 to 2 pi. Okay, then replace the value inside. You will get this one as a 8 tangent pi over 4 minus the 2 pi minus a 0. Simplify it. You will get this one as the a square 4 minus the pi unit square. Done. This will be the answer for the question number 6B. Move on. We have question C. Show that the point on C furthest from the initial line. Okay. Show that at the point on C furthest from the initial line, you will have these equations, and verify that this equation has a root between 4.95 and 5. So the initial line is the horizontal line. So if you're looking for the furthest one, That means that you're looking for the y maximum. Okay, so we're looking for the y maximum. So if we're looking for y maximum, then what we need to do is we need to change the polar, which is like this, from r to become y. So we know that the y is equal to the r sine theta. So I just need to multiply sine theta for both sides. Then you will get a sine theta tangent 1 over 8 theta. So this is the y. And you just need to differentiate dy d theta. Dy d theta is a product rule. Keep the left, differentiate the right. Plus keep the right, differentiate the left. So we can factorize it out with a 1 over 8 a sine theta secant square 1 over 8 theta plus the cos 8 cos theta tangent 1 over 8 theta. Okay, so we can factorize the 1 over 8 out. In order to get the maximum distance from the initial line, our dy d theta must be 0. So that means it's a 1 over 8a. The whole thing here, sine theta secant square 1 over 8 theta plus the 8 cos theta tangent 1 over 8 theta is equal to 0. Okay, so this cannot be 0. This cannot be 0 because the a is a positive integer, positive constant. And you can see the equation that they want you to show over here. You can see that these equations over here, no tangent, no secant, no tangent, no secant. So what I need to do is rejected. Only this one left. So over here, you multiply everyone by cos square theta, because a secant square plus cos, multiply cos square, you will get a 1. So I multiply everyone by cos square 1 over 8 theta. So you will get sine theta plus the 8 cos theta tangent 1 over 8 theta multiply cos square 1 over 8 theta. If you just simplify it, you will get sine 1 over 8 theta and cos 1 over 8 theta. Using the double angle formula, we can simplify this to become sine theta plus 4 cos theta sine 1 over 4 theta equal to 0. So this is what they want. Okay, so we just need to rearrange to the form that they want. Therefore, the 4 sine theta, 4 sine 1 over 4 theta cos theta plus sine theta is equals to the 0 shown. Now we want to show that there is a root between 4.95 and 5. So we let these equations equal to the f theta. Let 4 sine 1 over 4 theta cos theta plus sine theta. Okay, let it equal to a function. And substitute 4.95 and 5 inside the functions using the radian mode. Remember to change into radian mode. So this one, I straight away press the calculator. You get this one is less than 0. You get this one is positive, more than 0. So therefore, Because there's a changes of sign between, therefore the root lies between, the equation has a root between 4.95 and 5. Okay, so therefore the equations has a root between 4.95 and 5 shown. Okay, this is how you show it. Okay, so this is the answer for the question number 6C. Moving on, we have question number 7. A curve C that given as the equations of y equal to the x squared plus x minus 4 divided by x squared plus x plus 2. State the equations of the asymptote of C. So over here, actually we know that our horizontal asymptote will be the limit of x go to infinity. So we still write it like this. Just let the x approach to infinity. You have x squared plus x minus 4 over the x squared plus x plus 2. Then you can get the y is equal to 1. That is your horizontal asymptote. Okay. Then your x squared plus x plus 2 equal to 0. You have no real root. So that means, therefore, no vertical asymptote. Okay. So this is the answer for number 6, number 7A. Move on, 7B. We want to show that the y is between the negative 17 over 7 and 1, including the negative 17 over 7, but not including 1. Okay, so what you need to do is to bring the denominator go to the left-hand side. Okay, like this. Then you make this become x squared plus x minus 4. Then you will have y minus 1 x squared plus the y minus 1 x plus the 2y plus 4 equal to 0. So in order to have solutions, your b square minus a 4ac must have greater or equal to 0. Okay. Then you can expand and simplify, but I think I prefer to factorize it out. Then you get this one as the negative 8 y minus the 16 greater or equal to 0. So simplify further, you have a y minus 1 negative 7y. This is a plus. This is a minus 4ac minus the 8 minus the 16. Sorry. So this one is minus 17. Then you can factorize the negative out and then make it become y minus 1 equal to the positive 7y plus 17 less than equal to 0. Okay, so from here you will get your y between negative 17 over 7 and 1. Okay, so you need to highlight that when y equal to 1, okay, when y equal to 1, the whole thing over here have no solutions. Okay, so maybe we just write 1 over here plus x minus 4 have no solutions. Therefore, your negative 17 over 7, your y is between negative 17 over 7 and 1, not including 1. Okay. So, over here, that is the answer for B. Done already. Now we move on to the C. stationary point. So to find the stationary point, we have to dy dx it, no choice. Keep the bottom, differentiate the top, minus keep the top, differentiate the bottom, divided by the bottom square. We shall factorize the x 2x plus 1 out because it's a common factor. You have a x squared plus x plus 2 minus a x squared minus x plus 4 divided by the x squared plus x plus 2 squared. So you will cancel. You will get 6 of 2x plus 1 divided by the x squared plus x plus 2 squared. That is your dy dx. So your dy dx equal to 0. That means your x is a negative half. And when the x is a negative half, you need to find your y. So just replace the y inside. You get negative half square plus the negative half minus 4 divided by the negative half square plus the negative half plus 2. Press the calculator, then you will get the answer as negative 17 over 7. Okay, so this is the answer of stationary point. Therefore, your stationary point is negative half and negative 17 over 7. Okay, that is a stationary point. Done for the C. Now we move on to the D. We want to sketch a graph and state the intersections of the axis. So your y is equal to the x squared plus x minus 4 and x squared plus x plus 2. When the x is equal to 0, your y is a negative 2. When the y is equal to 0, your x squared plus x minus 4 equal to 0. Then your x cannot factorize it. However, we need to solve it by using the quadratic formula. So it will be b squared minus 4. You see here, it will be a 2. You will get x equal to the negative 1 plus the 17 over 2. Okay, so this will be your intercept. So your intercept, it will be 0, negative 2. Then the negative 1 plus 17 over 2, 0. And negative 1 minus 17 over 2, and then 0. So these are the intercept. So now we are ready to sketch the graph. We have the horizontal asymptote is a 1. Let's draw with the proper scale, but over here I draw with freehand. That is a y, that is a x, that this is a 0, that's a x. So your when the x equal to 0, your y is a negative 2. So negative 2, this is a negative 1, negative 2 is somewhere here. Then we have a negative 17 over 7. Negative 17 over 7 is actually negative 2.4 something. So this is negative 3. Negative 2.4 is somewhere here. This is the negative 17 over 7. Okay. So the graph will pass through this intercept. Okay. And you have a minimum. Minimum happen at negative half and negative 17 over 7. So negative. This is a negative 1 around here. So negative half is here. Is somewhere here. So your graph will be like this. And like this. This value will be a negative 1 plus 17 over 2. This value over here, it will be negative 1 minus 17 over 2. So done. This is the graph for the for this rational expressions, rational functions over here. Okay, so this is the answer for the D. Now we move on to the E. They want you to sketch the graph. Okay, so if you let this as a fx, okay, if you let fx is equals to the x squared plus x minus 4 over the x squared plus x plus 2. So in order to get this result, that means you must have a modulus inside. Then you will only get this. So in order to sketch a graph of modulus inside, what we need to do is based on the original graph. Okay, based on the original graph. Okay, your original graph is okay. -1, -2, -17 over 7. This is a negative half. So your original graph is like this. This is the original graph. So if you have this is the y equal to fx. If you want to sketch the graph of f modulus inside the function, then this part of the graph will be gone. This part of the graph need to be erased. Okay, so need to be erased away. Okay, so the one that you have over here, you just need to reflect about the y-axis, then done. Okay, so for this case, if you reflect, then this will be the graph. This one I need to draw properly. Okay, so this is a sharp corner. Please take note that this corner is a sharp corner, not a round corner. So need to make sure you show the features properly. So just now I told you that this is a -1 plus the 17 over 2. This will be the modulus of it. So modulus of it, that means it will be 17 minus 1 over 2. Is it? No, no, no. Okay. This one is the 1 minus a 17 over 2. Okay. It's opposite. Okay, opposite. So if that means if this is a, then this will be -a. That's all. Okay, so this is the answer. This is the graph after you find the modulus. But we haven't finished yet. Okay, we haven't finished yet because the question wants you to solve the inequality for less than -half. Okay, so to solve the inequality that less than -half, maybe this one we can erase away. So we just let them equal. Let them equal to the -half. So you will get -2 modulus x squared minus a 2 modulus x minus a plus the x is equal to the modulus of x squared plus the modulus x plus a 2. So you will get 3 modulus x squared plus the 3 modulus x minus a 6 equal to 0. Take away, divide everyone by 3. Then you can factorize it, modulus x plus 2 and modulus x minus 1. So continue here, modulus x plus 2 equal to 0 means your modulus x equal to -2. You need to reject it because it cannot be negative. Modulus cannot be negative. Then another one is modulus x minus 1 equal to 0. Your modulus x equal to 1. Therefore, your x equal to plus minus 1. Okay, so that means for a negative half, your intersections over here will give you 1 and -1. That is the meaning of it. They didn't require us to put them into the diagram, so I will not put them into the diagram. Okay. Then if we just say that from the graph, the solution will be x between -1 to 1. Okay, so from the graph, your x is between -1 to 1, not including -1, not including 1. Okay, done. This will be the answer for the question number 7E. And this will be the last question for this paper. So I'll stop the video. I'll see you next time. Bye-bye.